Let us now apply what we know about rational expressions in solving operations on rational expressions. Assuming that you know how to operate on fractions, you must not have any difficulty operating on rational expressions because they're more or less the same thing. Let's have our examples. In this example, we are asked to add two rational expressions. First thing we want to do is check their denominators. If their denominators are the same, like in this example, we can simply combine the two expressions by copying the denominator and operating their numerator. As a result, we get x squared plus 4x plus x plus 4 all over x squared minus 1. Simplifying the numerator by adding 4x and x, we get x squared plus 5x plus 4 all over x squared minus 1. We can then factor out the numerator, then factor out the denominator by difference of two squares. We get x plus 1 times x plus 4 all over x plus 1 times x minus 1. As you can see, we can simplify this further by dividing x plus 1 with x plus 1. We finally have x plus 4 all over x minus 1. In this second example, we notice that the denominators are not the same. First, let's see if we can factor the denominators. Well, we can no longer factor x plus 1. We can factor x squared minus 1 by difference of two squares. We get x plus 1 times x minus 1. We now find a way to somehow make the denominators the same without changing any of the expressions. We can do this if we multiply the first expression by x minus 1 over x minus 1. In doing such, we get the same denominators, that is x plus 1 times x minus 1, without changing the expression, since x minus 1 divided by itself is just 1, and any expression multiplied to 1 is equal to that expression still. We now have x times x plus 1 over x plus 1 times x minus 1 as our first expression. Now that the denominators are the same, we do what we did in the previous example. Copying the same denominator and operating the numerator, we get x times x minus 1 minus 6 all over x plus 1 times x minus 1. We distribute x to x and 1 to get x squared minus x minus 6. We can factor out the numerator as x minus 3 times x plus 2, and we get this as our final answer. Let's try a similar problem. In this case, we again see that the denominators are not the same. We think of expressions which we can multiply to the first expression and the second expression to make the denominators equal without changing the expressions. In this case, we multiply x plus 3 over x plus 3 to the first expression and x minus 2 over x minus 2 to the second expression. Multiplying, we get 2 times x plus 3 all over x minus 2 times x plus 3 plus 3x times x minus 2 all over x plus 3 times x minus 2. Since the denominators are now the same, we can now combine the two expressions, giving us 2 times x plus 3 plus 3x times x minus 2 all over x minus 2 times x plus 3. Using distributive property to the numerator, we then have 2x plus 6 plus 3x squared minus 6x all over x minus 2 times x plus 3. In the numerator, we add 2x and negative 6x to get 3x squared minus 4x plus 6. For this example, we are asked to multiply two expressions. This is perhaps the easiest among the operations. Multiplying two rational expressions means multiplying the numerator of one expression to the numerator of the other, then multiplying the denominator of one to the denominator of the other. So, in this case, we multiply 3x squared minus 6x with x squared minus 25, and x plus 5 with x squared minus 10x plus 25. We see that we can factor 3x squared minus 6x as 3x times x minus 6, x squared minus 25 by difference of two squares is x minus 5 times x plus 5. X squared minus 10x plus 25 can be factored as x minus 5 times x minus 5. Looking at this setup, we immediately know that we can simplify the expression. Simplifying by dividing the same factors, we get 3x times x minus 2 all over x minus 5. Finally, let's try to divide two rational expressions. If you know how to multiply rational expressions, dividing them would be an easy task for you. In dividing rational expressions, we look at the divisor, that is the expression that another expression is divided by, and get its reciprocal. In this example, the divisor is 25x squared minus 25x plus 4 all over 5x squared minus 41x plus 8. Getting its reciprocal means switching the numerator and the denominator. This gives us 5x squared minus 41x plus 8 all over 25x squared minus 25x plus 4. Then, and this is the most important part, we change the operation from division to multiplication. We then have this set up. We proceed to multiplication like what we did in the previous example. That is, multiplying the numerators with each other and the denominators with each other. This gives us 10x squared minus 28x plus 16 times 5x squared minus 41x plus 8 all over 2x minus 4 times 25x squared minus 25x plus 4. We look for expressions we can factor. We can completely factor 10x squared minus 28x plus 16 as 2 times 5x minus 4 times x minus 2. 5x squared minus 41x plus 8 is equal to 5x minus 1 times x minus 8. We can factor out 2 from 2x minus 4 and get 2 times x minus 2. When factored, 25x squared minus 25x plus 4 is equal to 5x minus 1 times 5x minus 4. Now that we have completely factored out the numerator and the denominator, we then simplify the expression by dividing equal factors. This will give us x minus 8 as our final answer.